pandemic is an information problem. With perfect information, the pandemic would be over in a few short weeks. Those not infected could congregate at will. Those infected would be isolated until viral shedding stopped and the pandemic would be over. We don't have perfect information, and we won't have perfect information. The Holy Grail we need to end the pandemic is much better information than we have now. We believe this Holy Grail can be derived from a clinical study with massive participation. Every person on Earth has two detectors preferentially positioned in their respiratory tract to sensitively detect COVID-19, smell and voice. All we need to do is transcribe these biomarkers and map them to mitigation signals that can end the pandemic. BioDrop is our app that transcribes these biomarkers that are highly associated with COVID-19. Now they have to be mapped to mitigation signals. While there's a flood of research that demonstrates these biomarkers are highly associated with COVID-19, the mapping of them to mitigation signals is not simple and is where lots of biomarkers fail. The problem is biodiversity. While human bodies are highly similar in broad functions, there is much diversity in the states and conditions of human bodies. This diversity confounds the mapping of biomarkers to actionable diagnostic, treatment, or mitigation signals. Medical science is full of studies and methods seeking to find useful ways of mapping biomarkers to actionable signals. Doctors go through extensive training to learn how to expertly discern useful signals from biomarker data. This need has fueled decades of research seeking to realize ways for computers to make these mappings. The whole field of artificial intelligence has been cultivated from its origins with the hope and expectation that machine intelligence could be derived to substantially enhance the mappings between biomarkers and clinical signals. To a great degree, the promise of artificial intelligence in medicine has been unrealized. While there are niches where artificial intelligence has made contributions to medicine, much of the promise remains to be realized. Both voice recognition and medical image processing have made great strides in the past decade through the use of deep learning convolutional neural networks. These forms of artificial intelligence hold great promise for medicine, and much research and development is underway. The major problem they face is the vast amounts of information required to train them, typically orders of magnitude larger than commonly seen in clinical studies. Deep learning convolutional neural networks are capable of mapping these COVID-19 associated biomarkers to useful mitigation signals. More difficult, but potentially possible, is mapping to diagnostic and screening signals. This is the kind of problem for which machine learning is particularly well suited. According to Eric Brynjolfsson of Stanford, MIT, and Harvard fame, the top two characteristics of problems suitable for machine learning are: 1, learning a function that maps well-defined inputs to well-defined outputs, and 2, large digital data sets exist or can be created containing the input-output pairs. What is urgently needed now is a massive clinical study to curate these large digital data sets. With such data sets, the likelihood is high that urgently needed actionable mitigation signals can be produced every day for every person on Earth. Our strategy is to recruit 1 million participants for this clinical study. Everybody with a smartphone is eligible to participate. We only need 1 million of those. Recruitment can be driven by two robust motivators. One, need to end the pandemic, and two, opportunity to share in financial benefits. The need to end the pandemic is obvious. The toll on human life and economic loss from the pandemic is overwhelming. Everybody wants to end the pandemic. Participation in this clinical study has a good chance of ending the pandemic sooner and lowering its cost on humanity. Given the high economic cost of the pandemic, there's huge economic value realizable from ending the pandemic. As such, the artificial intelligence that maps the biomarkers to actionable mitigation signals has almost inestimable economic value. This huge economic value can be shared with the participants in the clinical study to further motivate their participation. Monetizing this economic value occurs when the FDA authorizes the use of this mitigation signal under an emergency use authorization. Its value will derive from its scalability to every person every day. With FDA authorization, this signal can be used by every person every day to mitigate the pandemic. Countries all over the world will have the tool they need to mitigate the pandemic. It will make huge economic sense for them to pay reasonable fees for every person every day to use BioDrop. At $1 per person per day, the estimated fees for the U.S. to mitigate the pandemic exceed $40 billion. It's the Holy Grail that we need now.